Hello everyone. The topic of today's video is solving equations with square roots. So we're really going to be looking, we think about equations, right? Equations, every time we talk about equations, we're kind of building those onions, right? Trying to figure out or solve for a specific variable. So we're going to be doing that today, but we're going to be utilizing a new tool. We're going to be using our tool of square roots. And before we jump in there, I just want us to understand that every time we're solving equations, we're talking about inverse operations, right? We have our addition, for example, and the inverse of addition is our subtraction, right? We've got our multiplication, and the inverse of that is our division. Today we're going to see that we have an inverse for exponents. And the inverse of exponents is square roots, right? It's those square roots. And that's where that's going to come in today. So we're going to be looking at some equations that have exponents in them, like this first one. X squared plus 7 equals 82. And we're going to try to solve this equation to get x. So to do that, we'll start with our onion, right? Because we want to be able to visualize what we're trying to do here. We're trying to get rid of the exponent on that x. But before we do that, we've got to get rid of this plus 7. And what are we going to do to get rid of this plus 7? Right, yeah. So we're going to go ahead and subtract 7 on both sides to get rid of that 7. And we're going to get x squared equals 75. Okay. From there, we still have to get rid of this exponent. So I want you to think about what I told you a couple of moments ago. What is the inverse operation that for exponents? What's the inverse of exponents here? Right, so the inverse of exponents is roots. So in order to get rid of this exponent of 2, we're going to take a square root. Okay, if we think about what a square root means, remember if we think about the square root of 4, that's the square root of 2 times 2. And because there's a pair in that, the square root of 4 is equal to 2, right? Well, the same logic applies to x squared. The square root of x squared, well, that's just the square root of x times x. And notice that we have a pair of x's. The square root of x squared is just x, right? Because there's a pair of x's under there. So that helps us get rid of the exponent. We get x equals plus or minus the square root of 75. But we want to be able to simplify that. And so we get to practice a little bit more with our simplifying of radicals and square roots here. So to simplify the square root of 75, since it's not a perfect root, we'll go ahead and break that tree down. We're going to get, for 75, maybe we saw 25 times 3. And 3 is our prime number. And 25 will become 5 times 5. So the square root of 75 is really equal to the square root of 5 times 3. And let's think about pairs there. We have a pair of 5s. That means that a 5 gets to be part of our answer. And that last little 3 is stuck inside of the square root, right? So we're going to end up with our final answer here would be x equals plus or minus 5 times the square root of 3. So we're really kind of combining what we've learned in the past about solving equations with our new skill of simplifying roots, simplifying square roots. Okay, let's go to another example here. All right, I want you to tell me what the first step in here after we build the onion is. So go ahead and build your onion. Tell me what that first step is. All right, so if we built our onion, we would start with x. And according to the order of operations, or PEMDAS, the next thing would be the exponent. That's the next closest thing to this x, is this exponent of 2. Then the 3. Then the plus 5. So if you said subtract 5 on both sides, you had the correct first step. So good for you. We'll go ahead and subtract 5 on both sides, and we'll bring everything down. That's going to give us 3x squared equals 86 minus 5 is 81. Okay. What's the second step? What do you think I should do next? All right, so like I said a couple of moments ago, the x is most closely stuck to that exponent. The exponent is more close than the 3, so we're going to get rid of that 3. Since the 3 is multiplying, we're going to have to divide both sides by 3. And that'll take us to our last step. That's going to give us, the 3's cancel, we're going to get x squared equals 27. 81 divided by 3 is 27. Finally, we've got to get rid of that exponent, and we get rid of that exponent how? Right, we got to take a square root. To get rid of that exponent, we take a square root on both sides. The square root of x squared is just x. And that's going to give us x equals plus or minus the square root of 27. But we want to make sure 27 can't be simplified. So let's see if we can do anything to simplify 27. 27 is equal to 3 times 9. And 9 is equal to 3 times 3. So the square root of 27 is the same thing as the square root of 3 times 3 times 3. Well, there's a pair, so we can simplify. Pair of 3's means I get to take a 3 out, right? And that last 3 gets stuck on the inside. We end up with x equals plus or minus 3 square roots of 3. Okay. One last question. I want to give you a chance right now to put this together and try to do it on your own. We have this question that says 7x squared minus 11 equals 17, and I want to give you a couple moments right now to go ahead and try this and submit your answer. All right, so let's jump in and let's see if we got this correct. Step 1, after we've built the onion, right, we could visualize that onion. If that onion helps us, keep drawing it. Let's keep drawing it if that helps. Step 1 is going to be to add 11 on both sides to get rid of the minus 11. That'll give me 7x squared equals, when the 11's cancel, we'll get equals 28. Okay. Step 2, got to get rid of that 7, and we'll do that with a division step. And that will leave us with, when the 7's cancel, x squared equals 4. And finally, our last step to get rid of the exponent will be to take a square root on both sides. The square root of x squared is x. The square root of 4, this is a perfect root here. We know the square root of 4, it's plus or minus 2. And that will be our final answer. We don't have to do any trees or simplifying because 4 was a perfect root. Okay? All right, that's going to wrap up this little introduction to solving equations using square roots. Make sure that you got all this down in your notes. If you have any questions, jot those down as well so you can hand them off to me at the start of next class. And thank you for tuning in.